So guys, a very warm welcome. This is Ishant on behalf of Auribises, and I hope you are following the AI tutorials. And today we are going to work on the next part, which is how you can save the model. Now, typically when you are training the model, right, it will take a lot of time. So there will be some epochs after which you would have achieved some accuracy on your data sets. And you cannot think that every time you should be, running the model, you should be training the model, compiling the model, so as to get in the predictions, right? So what we can do is once we train the model, we can save the model. So saving the model means that we are going to persist the model weights so that if you are supposed to reuse the model, you need not to train it again and again. So once the training is done, we next time will save the part of this training time and will directly use the model instead. So we're gonna see how we are going to save the model. We'll follow our CNN image classification, and to be precise, we're going to work on this COVID-19 data set. So the same data set we worked previously earlier for the chest X-ray image classification. And as of now, I even don't know how many of you have used that tutorial to predict whether the image is COVID image or it's a normal X-ray image, right? So we'll see that as well. So I'll use the model with the Flask. So this is going to give you a sort of an application environment that how you're gonna write any AI app, right, with the Flask, right? Of course, there will be not much of decorations on the UI front, but of course you'll get a very comprehensive idea that how you have to work on your projects as well. So let us start, right? So before I begin, I'll just give you a very quick walkthrough on what we did on image classification COVID-19 chest X-ray dataset. So if you can recall, so we got this COVID-19 dataset. The testing and the training dataset had two classes each: COVID and normal. COVID and normal. So in the COVID, we got these X-rays, which are these few images showing the COVID-19 infections in the chest of a patient. And to that, we have a normal X-ray as well, right? So we got these normal images of the human, right, where we have no infections versus the COVID images having the infections, right? So this data set is available on Google, is available on Kaggle here and there. You can obviously get that. And I have already, I don't know if I've shared it or not, but I will share it in case I haven't shared it. So guys, COVID testing data set, right? So this is the data set with which you're going to train the model. And this is the data set with which you can test your model, correct? So what we did, we used TensorFlow, we used Keras CNN model, but here we even did some image pre-processing. So we got this API called image data generator, right? So for the image classification model, we pre-process the images, we rescale the images first of all. Then with the help of this guy called image data generator, what we are going to do is we are going to read the images, and we're gonna convert them into 64 by 64 with an 8 batch size, and we're gonna have a binary class mode for them, okay, ones and zeros for the images. So we got these training and the testing images, right? So this we have already covered. I'm just giving you a small walkthrough. So we created a CNN model, if you can see. So model is a sequential model. So it contains a convolutional 2D layer, then a max pooling layer, then again a convo 2D layer and a max pooling layer. Then finally you added a flatten layer, a dense layer, right? At the end of the day, we got a sigmoid function which will predict which class it is. Is it a normal chest X-ray or is it you can say a COVID infected chest X-ray? So compilation of the model has been done, right? And the fit generator function, right? With some epochs, with the training images and the testing images, we got this model created. And we even did some history for the model where we evaluated accuracy and the loss with respect to the training and the validation data set, right? So guys, let's try to run the same program. So this is the session 69, right? I'm just going to run this same program in the session 69. So we'll see now how it's gonna perform. So we have the data set available with us, and the TensorFlow is gonna do the job for us. So there are 130 images, right, for two classes in the training and 18 for the testing. So we got these 5 epochs, and the way you will train this model, slowly and slowly the accuracy will go high and the loss will come down, right? And one more thing which we are trying to do here is where we are going to plot the training and the validation accuracy and the losses together. Okay, so let's just finish. Let's just wait for this training to get finished. All right, so here we are, right, with the training accuracy and with the loss, right? So the training accuracy and the validation accuracy versus the loss, right? Now if you want to refine this model more, so I already gave you guys this part here on the TensorFlow tutorials. If you can recall, right, so there is this image classification tutorial which we already sort of followed. So in the images we got this image classification. So guys, this is the same way we have dealt. So you need to do some image augmentation where you can actually try to go better, right? So when you do this augmentation, you can do horizontal flipping, then you can try to rotate the images, and then you create the data set, right? So you don't have only one single image, you have images rotated to the left, right, you have images flipped horizontally, vertically, and you put it all together to have much better data set, so that at the end of the day you can sort of achieve a better accuracy and a minimal of the loss while you are doing the training and the validation, right? So this is what I actually offered you guys in that tutorial to proceed further with. And even if you will look into this session 66, I have given this part, right, for image augmentation. You need to proceed further. So always remember, this is where we have created and trained a model, but this model can be certainly refined more. Okay, so this is not that way we have perfectly refined the model. Now there is a format called H5. I'll just write H5 pi. So this is your H5 pi package, right, guys? This is one of the libraries for which you need to install it first. So you need to just say pip install H5 pi. So you need to come here and say this pip install H5 pi. Okay, so this library has to be installed. Now H5 is one of the extensions to save your model. This is one of the extensions to save your model. So once you are done with everything here and there, what I will do is I will say model.save. So save is the function which is going to save your model. So I'll say this model.h5. So simply use the save function to save the model, right? So it's not that challenging here. So H5 is an extension, right? And H5 pi is the library which you can install. So this is an HDF5 format which basically stores the tensors, right? So it's a format. The way you got file formats. This is a file format, right? And if you want to read more about it, so I'll just share a few more links here. So this is the first link. So I'm just gonna put up this. Please see pip install h5 pi. So read more here about the model dimensions, and this is HDF group, right? So guys, you can just read about the format more, but you need to just understand in a very simple way that what is what. So H5 format shall save the model weights. Typically, H5 format is to save tensors. So whenever I say tensors, right? So tensor means it's basically a huge n-dimensional array, right? So we're gonna save the tensor, we're gonna save the model in the H5 format. Let us try to run the program and see how it's gonna work for us. All right, so I'll just stop it. So just give me a moment. So I'll even write this basic print statement. So model saved, right? So we'll just come to know about this model saving or not. So you create the model. Now it works for any model, right? So either you are doing a regression problem or you're doing a classification problem, right? You can anytime save your model so that you can eliminate this training steps again and again, right? So we don't want to come up and do this training part again and again. So let this training get finished. So in this tutorial, we have not applied image augmentation. You can do so, right? So you need to follow the perfect part. So this is how our training accuracy was achieved, and this is how your training losses are achieved. Quite relevant and good enough to go ahead with it, right? So model.save, model save. So guys, if you will see here, now you will get to see that there would be a file called model.h5. Now this file is not a readable file format. If you try to open this file format here, so let's see this. So it is non-readable file format, right? It's 9.34 MB in total size. So it's quite a huge of a tensor when it comes to the storage part for your model. And there is one more format in which you can save. So you can ignore this .h5 format. So this h5 format was a bit previous model for previous versions of Kira. So TensorFlow says that you can directly say save your model like this, okay, with some name, of course. So this model goes here. So if you don't want to use h5, you can even just say model.save, give a name. Now let's see what will happen in this situation. So we'll try to run the code again. So two ways to save the model. So this is the latest approach. All right, but in industry, H5 really works, right? So it's not like that. The H5 is a very old format. So lot of places you will find that, okay, there are some saved models with the H5. Now, if you created some ANN model, you don't want to share the program, you don't want to share the code, you can share this H5 file so that people can use this model and use your model without using your program, your code, and they can further make the predictions. So the way we did see the cafe model in our last tutorial with respect to OpenCV and face recognition, right? So people will not share the programs, their code snippets, so rather they will share their intermediate stuff. So let's close this, and model is saved. And now what you will see is, so here guys, there is this folder called model which has been created, and this model here is going to have some variables, then some index, and this is the extension .pv, right? So TensorFlow is going to save your model with this extension .pv automatically if you don't mention anything. So this mentioned a model here is basically the name of the folder. So model is a folder in which model will be saved and can be any name of your choice. So same way guys, it need not to be model.h5 only, right? So this can be any name of your choice. Now anyone having any query can please raise the same. I hope this is clear till here, right? It's not that challenging thing. Can I get a smiley as an acknowledgement from all of you? Are we good to go? So we create an ANN model. We save that model in either H5 format, or you save the model directly. It's up to you, right? But the only thing is this, that if you have saved your model, next time you can directly use it without training it. That is the core benefit. Let's see how we can use it. So I'm going to create, let's say, one more Python file. This is your session 69A. So here I'm going to write a program where you will be able to see that how you can use a predefined model. Okay. So from TensorFlow dot Keras dot models import. So I'm going to import this guy called load underscore model. So this is the API load model from the TensorFlow Keras, right? So here what we did, so we use the Keras sequential dense convert to the other layers and here and there, and we finally did a save on the model. We saved the model in two formats. So there is this function called load model, from where you can load the model and then you can make the predictions. So how it's gonna work for us? So you say model is load the model, and you mention your model, right? So you say model dot h5. So we need not to create and train the model again. So it's gonna save your time, right? So you need not to do all those epochs here and there. So this is so much benefit to us. So no need to train the model. It's a predefined trained model. Guys, one line of code and you are done with it, right? But of course, yes, model can be compiled, right? So model can be compiled. So you have the model, but you, if you want, you can do this compilation on the model, right? So that you can achieve the desired results with the same loss optimizers and the metrics. Now, what next I'm going to do, right? So I want to predict whether this guy is giving me the correct outcomes for my images or not, right? So if you see now, I have this COVID-19 data set. So we trained the model, session 69. We just use this COVID-19 data set for the training, right? And we do have these testing images in the same COVID-19 data set. So both the classes, right? Now what I will do is, from the test, I'll use one image as COVID and one image as the normal image, and we'll see whether it's gonna predict us the correct thing or not, right? So for this, I'm gonna use OpenCV. So I'll say import CV2. I'll read the image with the CV2, and I'm gonna use this NumPy so that I can sort of, change the image size and all, or manipulate the image. So I'll say image is what? Image is your CV2 dot image read. Let's give the path here. So the path I'm going to use is this COVID-19 dataset slash test. So I'm going to test one image. So let's go to the test, and in the test I have these two images, normal and COVID, right? Two folders, normal and COVID. So I'll first of all test for the normal, and then we'll test for the COVID. So this is the normal image. So I have taken this hard coded path, right? So this is testing the normal image. So I've taken up this normal image, and once we got this image, right? So let us resize this image. So I'll say image is your CV2 dot resize. So resize the image. Let's take so in my, I have this image size as 64 by 64, right? So I'll use the same resizing, 64 by 64. Now for my image, I just need to apply one reshaping. So I'll just say numpy dot reshape. So in order to get this prediction done, so reshaping the image, it's gonna be 1 comma 64 comma 64 comma 3. So you can just print out the arrays and the shapes and you can see what exactly it is. So I'll say model dot predict underscore classes, and I'm going to pass this image now. So this image is going to give me some class of prediction, right? So classes, or I'll say just the class, right? Yeah, so class is a keyword, so let's use classes only. So model dot predict the classes for this image. So I can even pass more images. So let's say print these classes for us here. Let's run the code and see how it's gonna work for us. So TensorFlow in action. So guys, if you see here, I got the class label as 1. It's a binary classification problem. I got the class label as 1, right? Now I'm going to come here and take another image. So we got the normal as 1. So this is the first folder 0 and normal as 1. So let me take this image. So this is not the normal, this is from the COVID, right? So I got this folder COVID, and this first image is basically your infected image. Let's run the program again. So now we are really happy to see this, guys, that here we get to see that the label comes as 0, right? So when the label comes as 0, we need to understand that, okay, we have certainly came across something like that. We have a very good classification model which has been created, right? So 0 is COVID infected image and 1 is going to be your normal image. Guys, can I get a smiley? I hope you would have achieved a sense of satisfaction that we have done this image classification problem statement. Now it's basically a saved model. You are not training the model, you are just loading the model, applying the compilation technique, and you are using it. Now over here, what is the kind of homework which I want to share with all of you? Small assignment. So upon finishing the training, we have losses and accuracy. We have loss and accuracy. So after loading the model, validate if it has the same loss and accuracy as we trained in for. So what I'm saying is, you actually train the model, right? So when you train the model here, so you will have some loss and accuracy. So when you loaded this model here, so is it the same loss and the same accuracy with which you actually train the model? And try loading the model only. So what I'm saying is and not H5 format. See what happens if you actually work on this model load from the model, right? If you directly try to load this model instead of the H5 format. Okay, so explore that. So till here, I hope everyone is good to go. So now I'm going to put up so many things all together. Okay, so what I'm going to do is I'm going to certainly fuse the Flask application along with this image classification problem statement. So we'll choose one image from the user, right, and we'll tell him whether this is a COVID infected image or whether it's a normal image, right? So how you gonna work on it? Let's write one more Python file and work on that. So new Python file, session number 69B. So I'm just going to use a few of the previous code snippets. So in our session number 64, we had this upload image function, if you can see, right? So where we saved the file and then we rendered this success.html, if you can recall, guys. So I'll use the similar code snippets, right? So I'll just very quickly do some copy pasting here. So this session 69B is putting up image classification from the saved model. So we're going to put up the image classification from the saved model, right? And this is along with Flask app. So remember, whenever I'm writing this Flask app, I'm not using any cascading style sheets. I'm not styling the HTML web pages. So you can style the HTML web pages very well. Okay. So let's write an app here. So I'll just have one. I'll just directly use this function. So upload data set. So upload data set is going to be this somehow your URL, right? And there is one more URL called home. So this home for me is supposed to be sort of index page, right? So I'll just say this guy index. So in the index, I'm going to return this home.html. Let us see what is this home.html. So in our home.html, we wrote this so much of the program, right? Welcome to this LMS home, this, that, blah, blah, blah. But we got this select image to upload. If you can recall this, guys. So we got this select image to upload. I'll just use the same HTML file. So I'll say a new file. Let us name this image hyphen classification hyphen index.html. So this is one more HTML file which I have created. I'll just use the way home HTML is. So this is our COVID-19 X-ray image classification, or we'll just have it here. So COVID-19 image classification. Okay, so this is what we have to do. So I'll come here, I'll remove this. So I'll have only one thing here, that is selecting of the image. So please select X-ray image for COVID results, right? So you're gonna upload an image. So upload X-ray image. So this is going to be the button's value. And in my session 69B, so this index here is going to be what? It is going to be this image classification index.html, right? So this is the file which I want to use as my index page, right? So the moment we are going to click on this button, which is upload the X-ray image, this guy is going to take up a file, the name as image, and this is like upload image action. So here this upload okay, so I think this need to work out here. So action is upload image. So I'll just very quickly yeah, so this is the action, right? So I've chosen the wrong thing. So here we are, right? So upload image will be executed, and the file which you got is an image. You are saving this file here, right? You are going to save the file which you picked up, and then you are going to render the template with success.html having a file.name. So this success.html is going to be something like this, where I will write another new index file, I mean new HTML file. This is going to be image classification result.html. So I got this same success.html, but here I'll be having something a bit different, which goes like COVID-19. So we use the similar XRay. So I'm just going to say COVID-19 XRay results, right? So this is something which I'm going to bring in. So here I'm going to put up this class, right? So what is the class? And I'm going to put the name here. So we got this image classification index file from where you're gonna upload an X-ray image, and we got a result file which will display the name of the class. In my session 69b, the index of your app is going to load image classification index.html, right? From there you will upload an image, and after uploading an image, I am going to give this result. So here this success.html is going to be this image classification result.html. Guys, can I get a smiley as an acknowledgement from all of you? I hope we are good to go with whatever we have discussed so far. Wonderful. So in my 69b, I'll just put up the last part over here as we're gonna start this application. We're gonna start this application. Now here I can sort of write my program to do the predictions, right? So I can do the predictions here. So let us define a function, define predict COVID, right? So I'll just say predict COVID. So this guy is going to take the input as file name as input, right? So we'll take the file name as input. In my session 69a, whatever the code I did, right, I'm gonna write in there. So I'll import first of all these necessary required libraries. So we are going to have this model loaded. So we load the model here. We are going to test the image. So this image which you are going to test now is typically this file, right? So I'll just have it this as image to be tested, right? So this image to be tested will pass here as image to be tested. Now this label may be 1 or 0. So the prediction which we are going to do, right? So classes is prediction which you are going to do. If you will see in our previous case, we got some results. Let me run this code here. So this guy was giving us some results. So it says as 0, right? So what is this? This is list of list, right? So this is list of list. 1 was a COVID, 0 was normal. So I think so, right? So no, so 0 was coming for the infected case. 1 was for the normal. So what I can do is I can have this simple say label as COVID infected. So label is going to be a list, COVID infected, or this guy is going to be a normal. So 0 and 1, right? So I'm just going to say print me label of, so this is classes, right? So let this be classes here. So print me label of classes of, so I got this zeroth index, right? So zeroth guy is zeroth index. So if it is going to be infected, So it will show us this infected text, this label over here. So let me come here and try to run this program. Let's see. So it says it's COVID infected. This is the result. And if I choose the image which is above, right, which is the normal image, so this guy will give us the text as well, right? So I'm not gonna just rely on one part. So it says normal. So I think this works wonder for us. So I'm gonna use this part of in our 69B, right? So we're not just going to have the prediction on the basic parts. So we have these labels as COVID infected or normal. And what I'm gonna do is I'm just going to return this label from the function. Will return this label here. So whatever will be returned back. So I'm going to put this over here in the name. Let me show you how. So I'll say predict the COVID. The image to be tested is this your file name. This is the image which we have to test, and this is going to give me a label in return. And here I'll pass the label instead of the file name. That's it, guys, right? So let's see what we did. We created an index file. So this index file is going to be image classification. Sorry, my bad. This is not the image classification result. This is okay. So I think I did some blunder here. I have made both the things as result. Okay, so just give me a moment, guys. I'll just do a refactor. So this is supposed to be your image classification index, right? And this is supposed to be our result. So coming here, we have this as index, and this over here is supposed to be result, right? So we got this index file. From the index file, we're gonna upload an X-ray image. When you upload an X-ray image, you get to execute this upload image function. So upload image function will capture the file. We'll save the file in our system here, right, in our local disk here. Then we'll pass this file name to predict COVID function. This guy will use the predefined model, and it's gonna do some predictions, and hence we're gonna return the label of classes of 0 and 0. So whatever the image you choose, and thereafter this label will be rendered to the result page with this name as label, right? And the result page is going to display whether the infection is there or not. So I can even just come up and say this as results for X-ray image, right? So whatever the results are there, that are going to come up in this page. Can I get a smiley from all of you? Shall we execute the program and see how it's gonna work for us? Anyone is going to have any query can please raise the same, guys. And I hope you are enjoying this part of session now. You are able to understand that how you can write a small application for image classification, or even you can work on your projects now very well. So let's run this session 69B. So we got this project in action. Let's click on the link. So this is your COVID-19 image classification. Please select X-ray image for COVID-19 results. So you say choose file, upload the X-ray image. So I'm gonna choose a file now. Okay, so here I have this downloads. I got this image in the COVID-19 data set. So I'll use the testing data. Here we'll select a normal image first of all, and you say open. So we got this normal image, and you say upload the X-ray image. So we see that this guy is taking time, and very beautifully this guy has given us the result, that results for the X-ray image is normal. Isn't it amazing, guys, right? So let's try running one more program, one more use case here. So I'll choose one another file, which is infected file. So we'll go back here in the testing data set. Now I'm going to choose a COVID image. You say open. So upload the X-ray image. It says it is COVID infected. So we sort of, did worked on the real-time problems which are prevailing as of now. But at the same time, right, this is not something which can be medically trusted, because the data set which we are using is Googled up here and there, right? So if we possibly try to work with the government, if we get the X-ray data sets, we can definitely try to do something better in the same problem statement. So Sahil, we have used return a label over here, right? So in the session 69B here, predict COVID, we return the label from the classes 00, and that's what you get as a label, and we are sending it back. So that is the reason you get this COVID. I think we just misspelled this COVID infected. So this guy is just like here, COVID-19 infected to be precise, right? This is the label which we are using, guys. But I hope you understood what we have done so far. Anyone with any query can please raise the same. Okay, so Sahil, why you have used 00? Because when we are printing it, so it was giving us the result. So these classes is going to give us the result something like this, okay? Either 0 or 1. So array of array. So classes of 0 and 0 is going to give me this value 0. This may be 1, this may be 0. Good to go, Sahil? So this is a list of lists, right, which you get as a result. Yes, Pradeep. Yes, we can show the image. We can show the image file names, guys. Here you can even display the image. You can just have an image, a tag in the HTML, and you can display that, right? You definitely work on it. So I just hope that this is perfectly fine with all of you. So COVID-19 infected, right? So you can even show the image here. So you need to just have an image tag. So guys, in this result HTML, you need to have this image tag, right? And for the source, you are just going to give this image. So just use this image tag and display the image if you want to do that, okay? So at the same time, when you are doing prediction, what is the accuracy in the prediction? You can even display those scores. That may make the application look more better, right? But this is where I have just stepped in and help you guys with writing an ANN model, right? A CNN model, image classification from 0 till how we can write an app, and saving the model and reusing the model. So this is all for the day, guys, and now I expect that you guys would have kind of created some interest, and you would be able to sort of solve the problem statements in the real-time environment. Okay, so these are the files, session 69. So COVID-19 X-ray image classification with Flask and model saving. So I'm just going to push this program over the GitHub. Guys, you can now review the program. You can review the code snippets. Yes, Pradeep, I'll share the COVID-19 dataset in the WhatsApp group very soon. Okay, I'll do that. So I hope everyone is good to go here. So can I get a smiley so that we can close the session? Right, guys, thank you so very much. This is once again Ishan from Auribises. I hope you had fun. Thank you for being with me. Thank you.